We have a motor driver L298N. L298N motor driver for the motor connection, capacitor for the power 9 volts or up to 12 volts or more, ground, then 5 volts out with jumper settings, 3 jumper settings, capacitor, a voltage regulator, diode for to avoid overshooting of current, and to prevent back EMF. This jumper is used whenever we're going to use a voltage of up to 12 volts. Jumper setting is used. We're using a voltage of up to 12 volts for this terminal. Then this becomes voltage output 5 volts. If we're using more than 12 volts, we're going to remove the cap, the jumper, and supply separate 5 volts to the circuit, becomes an input. Because this voltage regulator can supply power to the IC, some of the power of the IC came from this voltage regulator IC. And these two caps, jumper wires, used for enable, so that we can use these 4 pins as an input. Another one, L298N motor driver. Then we have this GSM for cellular or GSM for phone. The antenna, and then this is used for any smartphone. Whenever we're going to use this for phone application or GSM, SIM 800L. Antenna, header, 2 headers included, and antenna, another piece of antenna. What's this? It's used for cellular or cell phone with 2 motor driver. Let us look at this motor driver. We are using this lithium ion battery, 3000 milliampere hour, 3.7 volts. Since they are in combination series, so we have 3.7 times 2, around 7.8 or 7.4, and is connected to the motor driver. Okay, 7 volts and then ground. The middle is the ground. Let us now measure the voltage. DC. So our input, we have 7.3 volts, the combination of 2 3.7 volts lithium ion battery. Each battery has 3.7 volts. The combination or the series combination of the two is 7.38 volts. That is measured across this terminal block, left side and the middle. Then for the output, because we have the jumper, the jumper now is connected with the jumper cap, then it will step down the voltage, this 7.6 into 5 volts because of that voltage regulator 5 volts. This now is a voltage supply also, a voltage out. It's 5.3 volts, and we have the power LED turns on 5 volts. This one is 7.6 volts, and the other the right side, and in the middle we have the 5 volts. Okay, I connected the motor driver and the supply to this robot car with the use of stand-up and some masking tape. Then we have this 5 volt supply. From the 5 volts, and the motor is connected to the terminal. That is the terminal. The other motor, this motor connected to the other block terminal. Oops, we can now check. Let us connect the supply. So LED turns on. We have now this LED is connected to the voltage regulator, that LED. And this is a dual H bridge type motor driver. So we have left and right motor. When we use these 5 volts from this block terminal connected, we're now going to touch the header. When we touch it, it rotates clockwise. The other one counterclockwise. And the third one counterclockwise, and the fourth pin clockwise. So we are having two bridge type. So by just injecting 5 volts to the, so this pin is logic control. We can make this two to rotate in a clockwise and counterclockwise direction by just injecting 5 volts here. We need to keep the header so that any enable A for the motor 1 and the motor 2 will work. So this is a dual H bridge type, dual H bridge motor driver for the left and for the right. This is figure 1 L298N motor driver diagram. So where is that? This is the actual module. We have the IC, And then two terminal blocks, left and right. We connected the gear motor to the terminal block. And we have this terminal block for power supply. We're using 7.4 volts positive to the left, then ground at the middle, at the center. And the output is 5 volts. This is voltage output. Using the jumper settings, it will connect to the voltage regulator. It becomes now 5 volts in this. So we have now the 5 volt supply and 7.4 volt supply. We have 7.4 and 5 volts. Now, there is a 4 input, the pin out. When I touch the pin number 1, motor 1 rotates in a clockwise. Pin 2 counterclockwise. Pin 3 is for the motor B, motor 2. It rotates clockwise, then pin 4 counterclockwise, some sort of that. We need to use the jumper to work with this input. So still the jumper, we will remove the jumper cap into this pin, so that we can able to use these inputs. This is a dual H bridge. It means we have two motor, dual, left and right. And the supply, we are using 7.4 volt supply and 5 volts using this terminal block. And the inputs, these are the logic control. You can inject a 5 volts here to turn the motor to rotate it clockwise or counterclockwise. This enable pin or jumper A is for the motor 1. So this pin 1 and 2. Then enable B is for the motor 2, pin number 3 and 4. Whenever we touch the pin, the motor rotates either clockwise or counterclockwise. So using this control, it is a logic control, we can able to manipulate the movement of the motor. Using we can connect it to the logic control, this logic control to the microcontroller, so that the microcontroller can controls the movement or the direction of the motor and the rotation of the motor, either clockwise or counterclockwise.